Basically, wait for her to join. Hey, hi, Lipsa. Sorry, it got dropped. Okay, so this is what it was. Now we will see here the syntax for creating one object is just this. Okay, we just call the object. Okay, now we will see how do you create an array of objects. How do you create array of objects? Okay, so in C, how you will create an array of objects? Char array is equal to to do 100, right? This is how you would create an array, correct? In C of or on a stack. Okay. So if you want to create it on a heap, what you would do? You put something like this and is equal to malloc 10 into size of cap, and you would say char star of something like this is what you would write, correct? Okay, this is your C way of doing it. C way of creating a array of characters. Okay, but in C++, what you can do is new, now followed by the object type and the square brackets. And inside the square brackets, what you do, you put number of objects that you want, 4, 40, 70, or whatever that you want, it gets created here. Okay. Any doubts on this line? Okay. So if you want
Yeah.
to create an array, you just put the square brackets here. Okay. Then the 4 objects will be created, and the four times the constructor of this object gets called. Okay. So when the constructor of this object gets called 4 times, what does it mean? All 4 instances that it gets created are initialized to a value that you wanted. Okay, correct. Then how do you delete it? You call the delete function followed by array, because this is an array, so you should tell the compiler that this is an array. Okay, so but if you see here, right, this is not an array. We didn't put a square brackets here, so you don't put a square bracket here as well. Okay, so now let's check. Okay, let's check whether this is creating 4 objects and calling constructor 4 times or not, and whether this statement is deleting the object by calling the destructor 4 times or not. Okay, so it got built. See, okay, now if you see create dynamic array of objects, where is the statement? It's here, create dynamic array of objects. This is the statement. What is it following? What is it mean? What is it that we see what is it that we should see post this is 4 times the constructor is being called. Now if you see object with instance, 1 is created, 2 is created, 3 is created, 4 is created. This 4 statements you see. Now where are these 4 statements coming from? These 4 statements are coming from the constructor object with instance, so on so created. Okay, you are seeing this 4 times. So every time you create an object, what you are doing, you are incrementing. You see different numbers, 1, 2, 3, 4, right? 1, 2, 3, 4. So what, how you are incrementing? So every time you create an object, you do a pre-increment. Okay, it is just a way of storing it, storing how many objects gets created. Now followed by the objects creation, you are seeing destruction, destroyed, 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 destroyed. Okay, 4, 3, 2, 1. So I think this we covered in destructors, creation of destructors also. I mean creation of arrays, array of class objects, wherein the last object gets which you create now will be destroyed first. 4, 3, 2, 1. The same thing is happening here. So you created 4 objects, you deleted it. So you saw the destructor 4 times. Now you see a statement after deleting dynamically created array object. Okay, this is a statement that you want. Now you see the same statement after deleting dynamically created objects. So with this, what we can prove is if you want to create an array of objects of class on heap, you do new followed by class name followed by this. Okay, and you want to delete the complete instances. This is how you should delete. Now let's see what happens if I remove this. If I just remove the bracket, see it got compiled. But what happened? Only one got destroyed, and you see a code application got crashed. Correct? Why is it? Because we removed this array. Now let's see. Now I'm replacing it. See, all the 4 objects got destroyed. Okay, this is the right way of creating an array and deleting an array on heap. Okay, any doubts on this? Okay, I'll take it as a no.
So, so why did you take that 10 one? Any means above that 4 you can take, right? That array,
Here 10 you are
the
saying.
size of. Yes, yes, yes.
This one, this is for malloc. This is in C how you would write if I want to
Oh, sorry,
create.
sorry. Yeah, you didn't run
This
the
is C
same.
way.
Okay.
This is
Okay.
commented. So in C, what you do if you want to create an array, this is how you write a syntax. Okay, this is a C++ way.
Mhm.
Okay, now we'll close this. Now we'll see the actual problems in this code. Okay, now let me call a function like this. Okay, so in your code, you are writing a program wherein you are you are splitting the functionality. Like somewhere you are creating the object. You have a function which create but forgot to release the dynamic object. Okay, so this function what it does is it is just creating the object, it is not deleting it. So he wants the function who calls him to delete it. Okay, so now before that we'll see what this guy does. What it does, this guy does, the main just calls his function. You see this here. Now you will see this print creating dynamic objects. Then you would just see the constructor getting called. Nowhere in the code you would see we have used the keyword delete. Okay, rest and all as commented. So you would just see object getting created. See, you would see create dynamic objects, but object with instant ones got created. That's all. You don't see a destructor for this being called. Okay. So what does this mean? You are not destroying this object. Okay. You are not destroying this object. So you are leaving the function who calls him, right, to destroy this object. Okay. So let's see. If I do something like this, right, what he is doing, he's going to create the object. He's going to create the object and he's going to return the pointer to the object which he creates. Okay, he's just going to return the pointer of the object he gets created. Now you have a PTR. Now here what you are trying to do, you are trying to delete the object. Now we will see whether the destructor gets called here. See, now you see object with instant one destroyed. What happened here? You since you added delete, is calling the destructor. Okay. So generally where and why memory leaks happens is you write some functions and you create it, and somewhere someone calls your function and he forgets to do this deletion. Okay. That is where memory leaks happen. Okay. Any doubts on this function so far? Like you are
No,
creating
no,
your you are creating a function, you wrote a function which is going to create an object, but he forgot to delete it. So you are effectively creating a memory leak. Okay. Now the how to overcome such problems. Okay. Now how to overcome such problems is what we would focus on this class. So in this class, whenever you create an object, every time you need to write delete. Okay. But is there an other way? Okay, is there another way wherein I will create the objects and I will tell the compiler to write the code to delete it? Okay, so I'll repeat the statement. So, is there any other way? Is there any other way wherein I'll ask the compiler to create the object? Okay, sorry, where I'm asking the compiler wherein like I will create an object dynamically. Okay, but I want you to put a code. I want you means I want the compiler to put a code wherever you think that object should be released. Okay. So this concept is called as smart pointers. Okay. So C++ supports this such requirements wherein you create objects on the heap whenever, wherever you want. Okay. But compiler will decide, okay, and put the code wherever that is required to release this objects. Okay, by many chance you are able to understand this.
yes. No.
So okay.
Means object will do everything. Means we will create the object.
Hmm.
Rest of the thing compiler will do.
Compiler will put the code to destroy it. Okay. So
Yeah.
how we can do is, but there is a twist in that. So how we can do that is you with the help of smart pointers. Okay. If you see in C++, you would see things like smart pointers. Okay. There are many CPP reference. Okay, so memory management, you would see unique pointer and weak pointer and all. This is of no use. Okay, so this is what we wanted to cover, unique pointer. So unique pointer has a lot of functions. Okay, a lot of functions or functionalities. Okay, like you can create an object, you can release the memory, you can reset it, swap it. There are a lot of things that this guy can do, but that doesn't add value for us. For us, what we wanted to do is how we can create an object dynamically, and how we can make sure, how we can check that the compiler is deleting that object or not. Okay, if we can do that, then we have covered the concepts wherein you can see the objects gets created on the heap, and compiler is putting a code to delete it. Even we release it or not, compiler is writing the code to delete it. Okay, so let me write this function. So typically whenever you are writing a code in C++ and you want to create an object, you would need to use this unique pointer concept. Okay, so what does unique pointer do? Okay, unique pointer is a wrapper. Okay, it's a actually function template wrapper. Okay, like you would have seen the class templates, right? I mean, the function templates, it just takes some data type. Okay, inside which it will you will do write some functionalities that you wanted to do. Okay, so unique pointer is nothing but a class. Okay, unique pointer is nothing but a class. What it does is, so whenever you allocate, I mean, the syntax for this unique pointer is this: std followed by unique pointer followed by what is the type of object that you want to create. I repeat. So you put the data type of object that you want to create here, dummy. Now followed by whatever the variable that you want to give. Then you say make unique dummy. What it means is, can you make me an unique pointer? Okay. What it does is, it will create a unique pointer of this class and return it to this, and this gets assigned an object of type. It's a pointer, but it's a unique pointer. It's not a normal pointer. It's a unique pointer. You see what is the data type? It's a unique pointer. Now, if you see here, right, it's a dummy star. That's all. Okay. Here, the class is there, but something is added on top of it. Okay. That is, this is called unique pointer. So what it does is, it will try to keep the object as long as the scope of the object is there. What it does is, it will try to retain the object as long as the object is there. So now here I created the object. Let me write rename it pointer to object, pointer to object. Now here what I did some operation on this object. So I created the object, I did some operation of the object, but did I delete it here? No, I didn't delete. Okay, what I didn't do, did I delete it here? I didn't delete it. Let's, okay, this some, let it be. Okay, so I didn't delete it here. Now let's see, let's compile this and see whether the compiler will put a destructor here or not. Okay, now the same thing here. Okay, what is the difference? It's the same thing. I created an object. No, I'll explain this later, but before that I'll see explain this. So I created the object, I used it, and I ended the scope. Okay. Post that we are doing some other operation. Now what is my expectation? I want compiler to put some destructor here. Let's see whether that gets done or not. Okay. Now if you see here, object with instance 1 created. Now this is our print function. This is it, print value function. If you see line number 21, we didn't put any delete function here. What we didn't do? We didn't put any delete function, but we are expecting a destructor to be called. Okay. See here. Yes. If you see here, you are seeing object with instant 1 got destroyed. So what it means is the compiler will put a destructor here if you are using unique pointers and all. Okay, that's a result for this. I mean, so far this is clear, right? Any doubts on this?
Yeah, it's clear.
Sorry.
Yeah, it's clear.
Okay. So if you see here, the scope means you are not using this object after this. So the compiler understands you are not using this after this. So it has put a destructor here. Okay. So now if you see line number 25, it's the same PTR obj, but it's with some different name. Okay.
Uh, Sir, the unit pointer works like a
So,
create a pointer, right?
sorry.
This unique pointer
Hmm. It will create a
works
unique
like a
pointer.
create.
Hmm.
Okay.
See, unique pointer is a class. Okay. This is just a class template. Okay. Like how we have function templates, it is a class template. वो क्या करेगा? So as long as the scope is there, right, it will return it.
Mhm.
Now this P object is actually getting destroyed here. What is it getting destroyed? P object is getting destroyed here. So when the P object gets destroyed, it is going to call the destructor of this P object is nothing but dummy ka destructor. So this gets destroyed, followed by this one,
The new.
this dummy ka
Mhm.
destructor. So this is a stack object. Technically, this is a stack object. This one or this one is a stack object, but they are pointing to object which is on the heap. See, this is a stack object which is pointing to object on heap. So when you are deleting it, right? Okay, if the data type is unique pointer, okay, so then he will see what he is actually pointing to and he will try to release them. Okay, so that is the code that he adds. Okay, so if you see in this, right, the scope ends here of this object. Okay, now
Mhm.
same way I created one more object here, object 2. Okay, ptr object 2, and I used it, but I am returning it. What I mean is I am returning it. When I say I am returning it, someone who is calling this guy, right, is going to use this. Okay, so in the main function, what happens? The main function is calling this function. Okay, this what it does, he creates an object and reads here, but here he creates an object and returns the pointer. Okay, now the object is not destroyed here. Now you want to use that object here. Now ptr. Now let's see, can I do this? If the object is returned, you would see this function is getting called, and this pointer is still valid, and the object should be destroyed here. Okay, so here you created one object that is getting destroyed here, but here you are creating one object and printing and returning the address, and again you are printing, and here is where the application ends, and you want compiler to put a code that will destroy what you created dynamically. Okay, you wrote the code for this. Now let's see. So object one instance, so this is for from previous, because this object got destroyed. Now if you see here, object with instance one is created. Okay, let me comment this code so that you will not get confused. Now assume we are just creating the object and returning the pointer. Okay, if you see, creating object by unique pointer, object with instance one got created. Now you called a print function, objects instance one, and some printing dynamically created object released after scope and data. Which one? Oh, it is some dummy print. Okay, don't bother about it. Okay, but here this should have been here. Okay, you returned the pointer from here. The pointer got returned. Now you did a print again. If you see, you called print. So what you did, you called a print here, you called a print here. Okay, twice you are calling the print here and here. Okay, but when is the object getting destroyed? Here, before the application get terminated. Main, in the main you have a return function. This is where the object is getting destroyed. Okay, so what does it does is the
Sir,
unique, yeah, please.
sir, one more time. Actually, I'm not able to understand. After return, what it is doing?
Okay,
After the return command.
okay, I'll tell you again. So what C++ provides is, the compiler is so intelligent that he will insert, delete a pointer for you.
Yes.
Okay, so this is the code that you have written. Okay, but once you compile it, right, what will compiler do is he will put delete ptr. you, you got what I'm trying to say here?
Yes, sir.
Okay, when he puts this, what will happen? What gets called when you say delete a pointer? What should get called?
Construct, destruct.
Yes, destructor gets called. So
Yes, sir.
destructor should get called. Now we will see this whether destructor is being inserted by the compiler or not.
Okay.
Okay, see what was the print before return? Delete, right? Delete, what should delete do? Destructor. So what is
Destruct.
the print here before it? Object with instant one destroyed. Okay,
Okay, sir.
so the compiler
Yes.
is putting the destructor for you. Okay, so why we need such thing is, okay, sometimes developer can introduce some bugs. Okay, or sometimes you are giving a library to someone where you would say, oh, first function will create object and you should call one more function to delete it. Okay, for some reason the person doesn't call the second function. What will happen? The memory that you created using the first function will not be released and it will remain forever. Okay, so
Okay.
so as soon as compiler sees, right, he just called the first function, he didn't do anything, and the scope of this variable is no longer needed. Okay, so that's
Yes.
when he will put the destructor on his own. So he is using his brain to release the memory. Okay,
Yes. Okay. Yes, sir.
so that's what the smart pointers is about. Now let's see. I think is what it does. The same thing it did here. I think it did here. Okay. What he did here is he created the object. He created the object, and he saw the compiler saw that you are not using p obj after this.
Yes, sir.
So he put a destructor here. So this is what this unique pointers is all about. So using unique pointer, you can create an object and see and ask the compiler to write destructors on his simp. And this is called garbage collections and all. You would see this in Java and all these concepts,
Okay,
which
sir.
has been adopted in C. Okay.
Yes, sir.
Now it should call destructor twice. It destroyed once, destroyed. Why? Because the scope ended here, other object scope ended here. Okay. Okay, what else is there? Okay, I think that's what I had for this smart pointer concept. Okay, so there are many other things like release and all. So instead of compiler to instead of asking compiler to do a release, can you do a release? Yes, I can. All that I need to do is pointer dot release. Okay, so here compiler put the destructor, right? Let's see, can I do this on my own? That's correct. Hmm. This is how you write a code. Okay, so now what you would say, now we'll test this whether release is calling the destructor or not. So if you by any chance you want to call the destructor, this is how you want to do with the pointer. Okay, we'll test this. Okay, can you release the object instead of compiler releasing it? Can you release it? Hmm. One thing before scope and dynamic object released after scope and where is this? Instant destroyed. You don't see destroyed here, but it got destroyed. Now let's see how it calls. It actually got released. Okay, but you didn't see the destructor being called. What would happen? Okay, only the pointer got released. Okay, I think the that will just release the pointer. It will not actually destroy it. Okay, this is a wrong one. Okay, you can't actually release it. Okay, it's just the compiler has to put the code to release it. The function release, what it does is it just forgets it. It is again creating a memory leak. Okay, if you call this release, what it does is this variable will be released. That's all. He will no longer point to this memory. Okay, so the object will still exist even if you call this. You are just assigning some null value into this, that's all, but you're not actually releasing it, if you call this. Okay, the best way is to let the compiler to put the code to release this object. Okay, so am I clear on this pointers, unique pointers?
Yes, sir. Yes, sir.
Okay. Okay, guys, I think that's all I had for today. So maybe tomorrow we can start. Okay. So this is what it had: new, delete, memory leaks, smart pointer concept. So all these are covered in today's class. There's just one is enough. Now maybe I'll cover the this operator. Okay, if you want, I'll cover this operator is needed. This I will cover at the end. I think this is very difficult for you guys to understand. Maybe I'll push it to the end. Maybe I'll start this inheritance concept, access specifiers, constructor, destructor role in inheritance. These things I'll cover. Okay. Any other things that you want me to cover?
Yes, so one doubt. Sir, does fetch command and release command both are same or it is different?
Okay. Fetch will get the address. Okay, what are the pointer jo release pointer where on this fetch you see? Which fetch you are talking about?
Uh,
Get
so
or
one not fetch, fetch
where is?
command. So for release, I was looking for what is like the purpose of release. So there I got that one fetch command is also used to retrieve the data from the memory. That's why that I was asking. Both are same or is it like different?
In this example you saw or where you saw?
No, 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 not sir. In this example, in that C++ Google only I have typed for that, so I got fetch there. For release in C++, I typed there only I got.
No, it's release in C++. This one.
Yes.
Where you are seeing release? They would have written their own code, I think. Create DC. This one, this example.
Mm-hmm.
I think they wrote their own code. It is some Windows code. Release.
Okay.
It is their own code. Okay, it is allocator. It is not at all using unique pointers. There is no unique pointers here.
Okay.
It is not unique pointer concept. I do not understand what does release function with the cleanup means. If release function is of PDCS. Now what type it is PDCS? PDCS is a DCS object. Or no, PDCS is a init data collector set. It is this object. It is not a smart pointer. It is not a unique pointer. It is just a plain pointer.
Okay, sir.
So, okay. Thank you guys. Thank you all.
Thank you, sir.